This example comes out of section 10.3, composite functions. Similar setup to a lot of our examples, we're just given a couple of functions called f of x and g of x. In this case we have negative x squared and we have x plus 3. Hopefully without too much trouble we have a sense of what those do look like. The first one a parabola facing down, and the second one a positive slope line with a slope of 1 that goes through positive 3. So a picture of the graph never hurts when later we're going to have to do some graphing. But f of g, in terms of the equation, just means take g and put it into f, which means we have negative x plus 3 squared. Graphing that, I hope, again, is not too difficult. It should be a parabola, but it's reflected, so it's upside down again, but it's also moved 1, 2, 3 units to the left. And so a very rough sketch, looking something like that. They could ask us domain and range. The domain is all real numbers. The range needs to be less than or equal to 0. Now g of f of x, a little bit different because it's negative x squared plus 3. Now, what does negative x squared plus 3 look like? Again, it's a parabola. Picture it as a transform parabola. Turn it upside down, but then move it up 3 units. So we have ourselves a parabola that looks very roughly like that. Again, without labeling or anything, which I would do if this was an exam style of question. The domain of it, again, is all real numbers, but the range is y has to be less than or equal to positive 3. Now, f of f of x is negative x squared, and then I have to make that a negative up front and squared. Now that is pretty ugly with all those negatives and all those squareds. If I square negative x squared, I get x to the 4th, and then I have a minus sitting up front, so negative x to the 4th. That one, I don't expect you to know what it looks like off the top of your head, because it's a 4th power quartic function, not something you run into a lot. You might be surprised what it does look like. At first glance, it looks kind of like a parabola. It's a little steeper, different shape, but this one is a quartic function, but it has a multiplicity of 4, meaning that it only has one 0. It hits at 0, 0, doesn't go up and down like is often the case with a 4th degree function. So, the domain and range, again, somewhat interesting. Domain is all real numbers, the range less than, y is less than or equal to 0. G of g means take x plus 3 and put it into the function of that plus 3. So you end up with actually a very simple function in this case, which is x plus 6, which 1, 2, 3, 4, 5, 6 has no restrictions on x or y. X can be an element of the real numbers, y can be an element of the real numbers. And again, if this was a test, I'd go and label a couple of points on each graph, but I'm pretty confident that with a graphing calculator, you could find those, and even without a graphing calculator, because these functions are fairly simple, you probably could find them anyway.